So we can now really finish our coin tossing example by determining the maximum likelihood. So where were we? We calculated the probability of getting 2 heads in 3 coin tosses. This probability was 3p squared multiplied by 1 minus p. Now, since p can vary, p is an unknown input variable, so we can interpret it as a function of p. And what we wanted to do is find the value of p for which this function is maximized on the interval 0, 1. Okay, now we have learned some way to solve this problem in the previous videos. So the first thing that we have to do is to determine the critical points. Now, to do so, we have to compute the derivative of the function f. What is the derivative of the function f? Well, we now use input variable p, but of course it's the same as using x. Now, what is the derivative of the function f? Well, we have to calculate, so we get 3p squared minus 3p to the power 3. So if we take the derivative, then 3p squared becomes 6p. And we have to subtract the derivative of 3p to the power 3. So if 3 goes down, we get 9p squared. And again, you see we can take out the common factors, 3 and p, and we are left with 2 for the first term and minus 3p for the second. Now, the critical points are the points where this derivative equals 0, so we have to equate this derivative to 0, and this is the case if and only if the first term is 0, so p equals 0, or the second term equals 0, and this means that either p has to be 0, p has to be 0, or p has to be equal to, well, 2 minus 3p is equal to 0, so 2 equals 3p, and that means that p is equal to 2/3. Okay, so we have two critical points, one of which is the left end point of our interval that we look at. So the second thing to do is to determine the scheme where we insert the endpoints and the critical points, and in total we have 3 of these, and what we should do is now determine the sign of the derivative. Now, what is the sign of the derivative? Well, between 2 of these points, the derivative is everywhere positive or everywhere negative. It cannot jump over 0, so to speak, because it is continuous. So we only need to calculate it at one particular point. So let us take the point 1/2 in the interval 0, 1, and so we compute the derivative at the point 1/2, and that is equal to, well, is it important what value it is? No, it's just the sign of this value. So this is a positive number, and if we subtract 3 times 1/2, which is 3/2 from 2, we get something positive. So this is in fact positive. Now, in this interval, we can do a similar trick, which we just select a simple value, so maybe 3/4, and we compute the derivative at 3/4, and again 3 times 3/4 is a positive number, but now 3 times 3/4 is more than 2, so we subtract something which is larger than 2 from 2, so we get something negative. And no, again, it's not important what the value precisely is, only whether it's negative or positive. Now again, so we have these signs, and now finally we can infer what how f looks like. So when the derivative is positive, f is increasing, and when the derivative is negative, f is decreasing. And so what happens when we start at the endpoint 0, we increase, so we get 0 itself must be a minimum. Then we increase up to some higher value, but decrease afterwards, so 2/3 must be a maximum. And finally we decrease when our p-value increases to 1, so we get a minimum at the right endpoint. So this maximum is sitting at 2/3. Now, and since it's the only maximum, it must be even a global maximum. So f has a maximum at p equals 2/3. It is the only value. Okay, the value, sorry, is the value at 2/3 equals, well, 1 minus 2/3 is 1/3, multiplied by 3 is 1, multiplied by 2/3 squared is 4/9, if I do it correctly. And it is the only maximum on the closed on the bounded interval, the closed and bounded interval. The endpoints belong to the interval, so this implies that it is a global. So really, at 2/3, the function has its maximum value. And so what do we get? This answer 4/9 is the probability of getting 2, or of throwing 2 heads and 1 tail, if we if p equals 2/3 would be our true value. Now, does it make sense that the best guess is 2/3? Well, based on the fact that we toss the coin 3 times and get 2, well, it's just that we have luck 2 out of 3 times, so this is exactly what this p-value is telling us. So in some sense, it is not very surprising. So in fact, what we already did is part 3 of the previous video. So it's namely inferring that we have a unique maximum, so it should be global. And we still have to decide about the minima, at least, well, it's not necessary here, but it's more as an illustration of our theory. So what do we get in 0 and 1? F has a local minimum. Now, is there any difference between the two? Is one bit worse than the other? Well, could we compare the values? F0 is equal to 0, and F1, well, is equal to 0 as well. So these are both, and we cannot go lower, these are both global or absolute minima. And then I see again that I've written global over here, where the book uses the term absolute, so I should do so. Sorry. But since I crossed since I redid this video already a number of times, I think it's not worthwhile to do it again.